So allow me to explain why I'm making this video. So I was watching some funny YouTube videos, you know, the typical cats falling off of things, clickbait thumbnail, try not to laugh challenge, 1,000,000% fail. So I left my computer, to go get some water. I left the video playing. As it turns out, when I got back to my computer, the video changed, and some guy was burning stuff with nothing but a punch, and the assistance of 2 acceleration-activated flamethrowers attached to his hands. So, without hesitation, I added that video to a little playlist of, ideas for a project, right? So, I do that, and, now, I didn't want to just copy his design, I'm a little bit above that. Not much, just a little bit, though. So, I decided I'm going to copy 90% of his design, change like 3 things, and call it my own. So, that's what I did.
The technical details of this flamethrower.
So basically, how my flamethrower is going to work is I will have multiple modified lighters where the limiter has been removed, and I will fill those up with liquid butane, which happens to be pressurized because it's wanting to expand into a gas, and so whenever you press the button, butane leaves the lighter. So then all I have to do is program an accelerometer sensor to detect the g-force of a punch, and if it's under that limit, it won't activate, and then if it's over the limit, it will tell a servo to rotate and pull down on the lever that the lighter has, and essentially release the gas out of the lighter. And then I will have an arc lighter in front of the modified lighters, so that when the butane gas is released, it goes through the arc lighter's arc, and essentially ignites and creates a bunch of fire.
The chemistry of butane.
Let me explain some of the chemistry behind butane. Essentially, there are 2 types of butane, N-butane and I-butane, or isobutane. N-butane is just regular or normal butane, and isobutane is an isomer of butane, meaning it's similar to butane, but not quite the same. Similarly, butane is an isomer of isobutane. Both butane and isobutane have the same molecular formula, C4H10, meaning that the largest discernible difference between these 2 isomers is the structural shape. To put it simply, this means that N-butane has single bonds connecting 4 carbons in a line with single hydrogen bonds surrounding the carbon. This makes it a hydrocarbon, more specifically an unbranched alkane. Isobutane is relatively similar. The largest discernible feature of isobutane is that it has a chain of 3 carbons with a 1 carbon branch attached to the middle. This means isobutane is a chain of 3 carbons with a methyl group at position 2. Isobutane is also a hydrocarbon alkane. More specifically, isobutane is an alkane that is propane substituted by a methyl group. Now that I've said all of the technical details of both N-butane and I-butane, let's take a look at some of the physical properties of these 2 hydrocarbons. Butane has a boiling point of negative 0.4 degrees Celsius, or 31.3 degrees Fahrenheit. Isobutane has a boiling point of negative 11.7 degrees Celsius, or 10.9 degrees Fahrenheit. This means that isobutane is much colder than butane, meaning it's more effective in colder conditions when compared to regular butane, which is a much less viable option for colder climates. Butane has a faint odor, but many people consider it to be odorless, which is why most butane has an added odor. However, isobutane has a faint gasoline odor. I believe that I am using N-butane. When I burn butane, I am causing a combustion reaction. This particular reaction, in its simplest form, looks like this: C4H10 plus O2. This creates CO2 plus H2O. In other words, it creates carbon dioxide and water, as well as the byproduct of heat, which in my case is fire.
The code.
Now, just because I want you to understand how bad I am at writing code, I am going to show you a little clip of me while I was actively troubleshooting the code I actually ended up using. I was just not thinking straight. I am really not that smart when it comes to code, if I'm being completely honest. Um, the problem I was having was the library I was using didn't really work for what I was trying to do. I needed to use the Adafruit one, and I wasn't. Okay, I've spent like half an hour just fixing like simple error messages. I'm so bad at writing C++. It is unbelievable. But as you can see here, it's barely a page of code. In fact, if I got rid of all of those unnecessary gaps right there, it would be one page of code. And yet, here I am with error messages. I'm just trying to upload my sketch, okay? And I think it should work now. And it's done. I am so happy.
Basic design.
Alright, so basically, this is a drawing of the internal mechanism of a lighter. I drew this up for the purpose of basically just getting a good idea of what I'd be doing to modify the lighters, and also just because I really wanted to draw something and I was kind of bored. Basically, this is the button. It's a spring-loaded button. It's not actually 100% accurate, but everything's scaled up. The drawing itself is scaled up. I mean, in general, it's kind of cool, but my designs kind of go downhill after that because flip some pages over. Here's actually what I drew for the reference. So this is the first one I did. Over here, this is the more modern one. There's a few discrepancies, let's call them. Mainly the little lever here didn't work. I'm using a paperclip instead. And then I think lastly, just the MPU chip is actually where the pins are, and the pins are where the chip is. Other than that, everything is almost identical in this one, and it's to scale for the most part. A little bit, a little bit better. That's about it.
Custom tinkercad 3D printed model.
So this is a photo of me midway through the process of making my tinkercad model, and this is a photo of what I actually ended up printing.
Final assembly process.
Okay, I'm doing a voiceover because I didn't explain it well last time. Basically, I have a soldering iron now. I didn't have one before, but I do now, and I'm soldering an MPU 6050 accelerometer sensor. Okay, so now that I've 3D printed those things, I put the arc lighter right here in some red tape and just some red electrical tape, I believe, and just right through the 3D printed part for it. And I added some Velcro to the 3D printed, the other 3D printed part, the main part. And then the lighters also have the opposite Velcro so that they get held down properly. So in the last video, I didn't actually have the time to do like a little bit of a cringy little like crappy montage thing. So, I just kind of showed that, ooh, the LEDs turned on, crazy, wow, I'm such a genius. And then after that was the end of the video. It was really anticlimactic. So I figured instead I'll just actually do a montage. It's gonna be the worst thing you've ever seen. Seriously. The video just gets worse. And remember that fire is only dangerous if you're an idiot and you burn things that you shouldn't. That includes people, by the way, you psychopath. All jokes aside, though, if you made it to this part of the video, then you're pretty epic. Now for some end credits.